Okay, welcome. I'm going to put my ugly mug up on the screen here real quick. Um, Welcome back. Glad you got through the first part, and now we're going to try and get the second part done. It's probably going to be chopped up here a little bit because I've got to go somewhere at about 10:30, and it's now, as you can see, the clock on the wall, as George Thorogood would say, says 10:08. Well, actually, in one give me one whiskey, one scotch, one beer. I think it's the clock on the wall reads 3 o'clock. Last call for alcohol. Anyway, um, I I'm going to interrupt the flow of the thing. We're going to kind of leave sports for a minute because I left that one thing on the kilogram, and one of your fellow students, Misty, sent me this uh, thing on redefining the kilogram, which is so cool because um, here it is, redefining the kilogram. This is from the National Institute of Standards and Technology, and was founded in 1901. It's an institute that was founded in 1901, and is part of the U.S. Department of Commerce. Department of Commerce, because when you do commerce and you're dealing with things that have mass, or especially if you're here on Earth, everything, certain masses have the same weight. So that's why we can say 2.2 kilograms equals 1 pound, when actually, if you go up in space, that won't be the case. But anyway, so it looks like they're going to finally get it at 2018. Now all I need to do is explain to you what the Planck constant is, which is beyond the scope of this course. What the Planck basically, Planck constant is an energy measurement. You take the Planck's constant times the frequency of the wave of a beam of light, or a laser, or an electron moving about, and you take h times its frequency, and you get the energy of that light. And so, and Planck measured that constant. It's to 10 to the negative 34. So they've got to get it pretty darn accurate here. And then, then you'll have two things. You'll have the kilogram using Planck's constant, and you'll have the kilogram using the number of atoms of silicon atoms in a sphere. So that's kind of cool, actually. Anyway, so there's that. I just wanted to kind of talk about that real quick. But in the interim, let's go ahead and get back to our lesson here. And thanks again, Misty, to me. I was like, wow, this is so cool. All right, first thing I want to show you is a video. I've got to turn off. We're going to go completely bonkers here. Outlook. How do I turn it off? Quit Outlook. Go away. Please go away. I don't want to ever see you again this morning. I don't want to see Outlook until frickin' 4 o'clock. There we go. Jeez. It's driving me nuts. I about said another word. But anyway. All right, so let's get down here to conversions. All right? Let's get down here to conversions. Okay, now, how do we convert things? Let's get out some notes here. Let's take a look. All right, got everything plugged in. Let me turn this on. Yeah, close. Shut up. All right, there we go. Hold on. I'm waiting for my ladybug to come on. I forgot to turn her on before I started yakking at you all. I was so excited about this kilogram thing that I saw. It's a nerd thing. Okay. There we go. Now it should come on. Okay. Here goes two. All right. All right. But anyway, so lesson 1, let's do some conversions. Okay. Now, I'm going to, the easiest way to do conversions, if you want to, okay, kilometers to miles. Let's see, right there. kilometers to miles. I mistyped it. So 1 kilometer is equal to 0.62 miles. Now, when I was in Okinawa, when I was stationed in Okinawa, I was there for 6 years, 3 years, I did two different 3-year tours there, and everything was in kilometers. There was a quick and dirty way. There's a quick way to convert kilometers. I'll just show you real quick. To convert kilometers or even kilometers per hour to miles per hour to miles, or per hour, kilometers per hour, since they're both per hour to miles per hour. Since the hours here is in the denominator on both of them, you can do it. But the way it's real simple. What you do is you take 100. If it's 100 kilometers, that'll be about 60 miles, 61 miles. So what you'd do is you'd take 100 divided by 2, you'd have it, and add 10%. And you wind up with 60, which gives you a real good approach when you're driving and your speedometers in kilometers per hour, just to get an idea of how fast you go. So if you're going 40, then your miles per hour, you'd have it. Add 10% of the 60, which is 6, and you're going about 36 miles per hour. It's a real handy. There's all kinds of handy conversions like that. And when we get to the Fahrenheit thing, there's a quick and dirty way to do that one too. But one of the biggest conversions that we're going to use, so that's why on this thing, it's all fine and good. 1 kilogram. This is kind of misleading because, see, now when I came up with that 160 equals 160. Sorry, on my ladybug I made a mistake. We're kind of close here. Anyway. One of the biggest conversions that we're going to have to do is getting miles per hour, because what are the 3 units that we always use? The 3 units we always use are kilograms, meters, and seconds. Okay? And so, but you're very used to seeing things like 88 mile an hour fastball. Okay? If you watch any baseball, that's kind of a changeup, actually. 88 miles an hour is a changeup, or it's an older guy throwing his fastball. All right, and I want to get that to meters per second. Well, how the heck am I going to do that? How am I going to get 88 miles per hour? This will be the end of segment 1 once we do this. 88 miles per hour in meters per second. Well, here you go. So you got 88 miles. Let's just write it out this way, per 1 hour. All right, so we got to get rid of the hour down here. Put it up here. Well, but I got to multiply this by 1. So how many but I want to get seconds down below here, because this is seconds here. Okay, so I want to get seconds down here. How many seconds are in an hour? Well, there's 60 minutes in an hour times how many seconds are in a minute times 60 seconds in a minute. So those minutes cancel here. I wind up with 3,600 seconds. So I've got 88 miles divided by 3,600 seconds. So that's how many miles in a second I'm going to go. Times, I've got to convert the kilometers. I need, I know that there are 1,609 meters in 1 mile. So now the miles go away. So basically I'm taking 88 times 1609 over 3600, which gives me a nice constant I can multiply by every single time. And I'll show it to you on my calculator. So exciting. Finally, we're getting to the calculator here. All right. So I've got 1609 divided by 3600. Boom, 0.4469. Let's go with 0.447. So if I take 88 times 0.447, and this will be our conversion for miles per hour into meters per second, times 88 gives us 39 meters, 0.3 meters per second. Okay, that's page 1 of the notes. And let's stop here.